Hey guys, this is Miss Mann. I'm going to walk you through your Unit 4A formal on angles and parallel lines. We're going to run through the problems as quick and painless as possible so that you can get a better understanding of what you may have gotten wrong on your test. Questions 1 through 8 involve your vocabulary. So I just kind of condensed this for you and made it a little bit more simple. An angle is the intersection of two rays at a common endpoint or a vertex. Here's a picture for you here to look and see what that looks like. So that answer was G. An adjacent angle are two angles that share a common vertex and side. So this is an angle and then another angle, and they share that common side. Doesn't always have to be right. I know it looks like a right angle here. It doesn't always have to be. And that matched with answer F. Vertical angles are congruent angles that are across from each other on intersecting lines. So here we have the blue ones and then the red ones that match with answer E. Complementary angles are two angles with measures that have a sum of 90 degrees. So it can either be at a right angle or just two random angles that just happen to add up to 90. They do not have to be adjacent or side by side. They can be separated. Supplementary angles are two angles with two or more angles with measures that have a sum of 180, which match answer B. Here we have also a linear pair, which we're going to talk about in a second. And then again, just like the complementary, they don't have to be side by side. They can be separate. We usually see it like the first picture though. There's also a third thing that we might see, and it's all three of these. On a straight line, we could say that all three of these are supplementary as well because they add up to 180. So be careful that it's not just two. It could be more than that. But more often than not, this is what you'll see, which leads us to a linear pair, and they are specifically adjacent angles that are supplementary. So it's a pair of angles, just like our first picture here, that matched with answer H. Perpendicular, this is another symbol that you might see, are two lines that intersect and form a 90-degree angle. Answer C. They cross, they form 90-degree angles on all four sides. A bisector is a line, ray, or segment that divides an angle or a segment into two equal parts. So here, EG is your angle bisector, and it breaks up that whole angle DGF into two, which is 42 degrees and 42 degrees. Or we can have a line bisector, which would break these off into two congruent pieces. Question 9. If K is a midpoint of JL, JK equals 8x plus 11 and KL equals 14x minus 1, find JL. So the first thing I want you to do is draw a picture. What does it look like? If I have K as the midpoint of JL, here is my line JL and K is smack dab in the middle. That's going to mean that this side is congruent to this side. Then I can put in my labels as my measurements. Then we can say, okay, our midpoint means that the segments are congruent. That's what the tick marks. And if they're congruent, then I can set them equal. Then we start moving things around to solve for x. So we're going to subtract 8x first on both sides. So 11 equals 6x minus 1. I'm going to add 1 on both sides. So 12 equals 6x. Divide by 6 on both sides. X equals 2. Now, you might think that you were done. However, the question said find JL. You need to plug it back in. A lot of you got this wrong. So JK is equal to 8 times 2 plus 11. We're literally just plugging that x value back in. 16 plus 11 gives you 27. JL is 2 times JK because remember they were the same thing. So 2 times 27 equals 54, and JL equals 54. 10. If line N bisects, cuts in half, CE, find CD. So you can also say that they are a linear pair because they are both sitting on a line and they are supplementary. So we can say, okay, well, the first one plus the second one equals 180. Combine like terms. On the left side, we would add and subtract. You do not change signs if they're on the same side. But now I want to solve for x, so I'm going to add 15 to both sides. 5x equals 95. Divide through. X equals 39. But is that the answer to my question? No, because my question was find CD. So now we have to say, okay, CD equals x plus 6. Plug in x, 39 plus 6, and CD equals 45. So you have to plug it back in. 11. Find the value of x. All we've been given is this diagram here. I notice that they are both sitting on this line right here. So again, a linear pair is supplementary. 7x minus 1 plus 6x minus 1 equals 180. Combine like terms. Move the 2 over. So 13x equals 182. Divide both sides by 13. X equals 14. Then you should ask yourself, did I answer the question? All it asked was to find the value of x. So yes, we are done. X equals 14. Find the value of x. So we will not have to plug in anything once we solve. Now here I have two angles that are across from each other at intersecting lines. This means that they are vertical angles, and that means the angles are congruent. So I'm going to set those equal to each other. I'm going to start moving my variable over. So I'm going to subtract 5x from both sides. 4 is now equal to 3x minus 71. I'm going to move the constant over. So add 71 to both sides. 75 equals 3x. Divide through by 3. X equals 25. All I needed was the value of x. So x equals 25. Angle E and angle F are supplementary. If the measure of angle E equals 9x minus 38 and the measure of angle F is 2x plus 42, find the measure of angle F. So the first thing we have to decide on is, okay, what does supplementary mean? Supplementary means that they add up to equal 180. So then I'm going to take each one of those angles, angle F and angle E, and add them together to equal 180. I'm going to combine like terms. I'm going to start moving my constant over, so I'm going to subtract 4. 11x equals 176. Divide by 11 on both sides. And then x equals 16. Draw some lines here for you guys so it'll make a little bit more sense. X equals 16, but does that answer my question? No, I needed to find the measure of angle F, so I need to plug that back in. So the measure of angle F from our question is 2x plus 42. I'm going to take that x value that we just found, 16, and plug it in. 32 plus 42 gives me 74. So the measure of angle F is 74. Question 14. Angle 1 and angle 2 are vertical angles. If the measure of angle 1 is 6x plus 11 and the measure of angle 2 is 10x minus 9, find the measure of angle 1. So first thing we have to say is, okay, what does vertical angles mean? Vertical angles mean that our angles are congruent, so we can set those equal to each other. Start moving the variables over to solve. So we're going to subtract 6x from both sides. 11 equals 4x minus 9. So I'm going to move the 9 over. I'm going to add it to both sides, so it's the opposite. 20 is equal to 4x. Divide through by 4. X equals 5, but that does not answer my question. The measure of angle 1 taken from the problem. Measure of angle 1 is 6x plus 11. Plug in the 5 that we just found. 30 plus 11 gives me 41. So the measure of angle 1 is 41 degrees. The measure of angle G is 6 more than twice the measure of H. Then I'm told G and H are complementary. Find the measure of angle H. Okay, so this one was probably one of the harder ones. We need to piece this out one thing at a time. The measure of angle G. I'm given all this information about G, but no information about H. Well, what do we call things we don't know? X. So the measure of angle H is equal to X, which would mean that G is going to be 2 times X and then plus 6 because it is twice the value of H plus 6 more. So 6 more than that. So now that I have these defined, now I have to say, okay, what else do I know and how can I solve this? H and G are complementary. Complementary means that they add up to 90 degrees. So I'm going to say, okay, the first one, H, plus the second one equals 90. Combine like terms. Subtract over the 6. So 3x equals 84. Divide through by 3. And x equals 28. Now, what happens to be really nice is we already said that the angle H was equal to x by itself, so we don't have to do anything else. So the measure of angle H is 28. This one was harder. This one was also one of the more challenged problems, but we're going to walk you through it. QS bisects PQR. QS bisects PQR. So that means this and this, by definition of bisect, are congruent. So bisector means that PQS and SQR are congruent. So I can set those equal to each other, move the variable over, so 3x minus 6 equals 15. Add 6 to both sides, 3x equals 21, divide through, x equals 7. Okay, well, what am I trying to look for? PQT. Well, that's an interesting problem because PQT is way over here. This guy right here. So that's what I'm looking for. But I just found the value of x in one of these guys right here. So if I can plug x in that I know into this one, maybe we won't call this one x, we'll call this one y. If I plug x into this angle measure, double it, then I notice that this whole angle here makes a linear pair with this one, then we can get somewhere. So the next thing I want to do is PQR, this whole angle here, the one that makes a linear pair with PQT, is 2 times the measure of PQS. So I'm going to plug in that 7 into PQS. PQS was 7x minus 6. This value right here, 49 minus 6 times 2 is going to be 86. So now I know that PQR and PQT make a linear pair. So I'm going to add the two together to equal 180. I'm going to substitute in the values that I know. Then I'm going to subtract on both sides. So the measure of PQT is going to be 94 degrees. That one had several multiple steps. The more familiar you get with your vocabulary, the better and the easier that these are going to be able to work through. Use the figure below and letter options A through E to identify the relationships listed in questions 17 through 21. So 17, I want to look at 9 and 16. 9 and 16. 9 and 16. Well, if I look at this, I have two parallel lines and this transversal. So how do those two relate? I can kind of ignore this line up here because it's not involved. But these two are definitely on the outside and they are on opposite sides of the transversal. So in this case, it's going to be C, our alternate exterior angles. Next one, 3 and 6. 3 and 6. We have switched lines, so we are now on line A. My two parallel lines here. So now I notice that these are on the inside of my two parallel lines, which is going to make it interior. So either B or D. Now they are on opposite sides, so that is going to be your alternate interior angles. They are on the opposite sides, but they are still on the inside. 7 and 15. 7 and 15. They both sit on this line. Then I have these two parallel lines that they are in contact with. So notice they are in the same spot, but on the two different lines. So in this case, we have some corresponding angles because they correlate and they correspond to one another. 1 and 10. 1 and 10. Now, if we draw our transversal that they both sit on, but we perhaps draw it a little bit nicer for you. And then my two parallel lines, okay. Well, they are on alternate sides, okay. But I have one that's on the exterior and one that's on the interior. I don't have anything that's one or the other. They're either alternate interior, alternate exterior. So my only other option in this case, especially because they're not in the same spot, is E, no relationship. We could find their values if we really needed to, but they have no specific relationship. Process of elimination would put D as the last one, but let's take a look really quick. So 8 and 12. If we look at these, this is the transversal that they sit on. We have parallel lines A and B. So in between, they are on the same side of the transversal, and they are on the inside in between those two lines. So that is why this is going to be your consecutive interior, because they are on the same side and they are on the inside. 22, if line L is parallel to line M, find the value of x. So using those same angle relationships that we were just talking about, we're going to start solving some problems. These two are on the same spot but different lines. These are going to be your corresponding angles, and corresponding angles are congruent. So 8x plus 20 equals 11x minus 31. We're going to start subtracting over so that we can get our variables together. 20 equals 3x minus 31. I want to move the constant over to get the x by itself. So I'm going to add 31. 20 plus 31 gives me 51. 3x comes down. I'm going to divide through, and x is equal to 17, which is right there. Again, line L is parallel to line M. Find the value of x. Now this time, this one is pointing on this side, this one's pointing on this one. They would be on the same side of this transversal, and they are on the inside in between our two lines. So they are consecutive interior angles, and consecutive interior angles add up to 180. So 9x minus 4 plus 5x plus 16 equals 180. I want to combine like terms. So 9 and 5 give me 14. 16 minus 4 gives me 12. Start moving over the constant, so I'm going to subtract 12 from both sides. 14x equals 168. Divide through by 14, and x is going to be equal to 12. Last but not least, we have our true-false category. We're going to use this diagram here to answer some of the questions, and we're going to assume that lines J, K are parallel, and L, M, and N are all parallel to each other. Question 1. 1 and 6 equal 180. Let's look at angles 1 and 6. Okay, well, if I'm looking at angles 1 and 6, they are sitting across from each other on this intersection right here. So these would make it vertical angles. Vertical angles are congruent. They are not supplementary. So that would make this statement false. Angle 11 is congruent to 15. Let's take a look at 11, and 15 is right beside it. That would make these, because they are sitting on the same line and it's cut between them, these would be a linear pair. Linear pairs are not congruent. They add up to 180. They are supplementary. So this statement for 25 is false. 19 is congruent to 16. 19 and 16. So let's look at how the lines correlate to them. That is the transversal that goes between them. They are sitting on these parallel lines. They are on the inside between lines M and N, so that would be interior. They are alternating because they are on opposite sides of that transversal. Alternate interior angles are congruent, so this for 26 is true. Angle 12 and angle 4. 12 and 4. So we have this parallel line and this one, and then the transversal that goes alongside of them. If I notice, though, they're both in the same corner of those two intersections, that would make these corresponding angles for 4 and 12, and corresponding angles are congruent, so that is true. Last but certainly not least, 13 and 17. 13 and 17. 13 and 17, we're going to draw in this transversal along our two parallel lines. So they are definitely on the interior between those two lines, but they're on the same side of the transversal. They're not alternating. So same side, consecutive interior angles are supplementary. They add up to 180. They are not complementary. So this one in this case is false. Remember, all angles with your parallel lines are either going to be congruent, equal to each other, or supplementary where they add up to 180. That is your test, guys. I hope this explanation of some of these questions was really helpful for you. If you would, please now start working on your quizzes questions to help get that extra practice before you take your next test. I know you're going to do really great. If you have any questions, please don't hesitate to ask. I would love to help you be able to get mastery on this.